In this video, I wanted to go over a sample question that is slightly more challenging. So this is going to be question 11 in the handout problem set. And in this question, I am being asked to solve for x element of complex numbers. Okay. All right, so I have 1 over x times x plus 2 minus 1 over x plus 1 squared equals 1 over 12. Since the denominators are already factored for me, I can go ahead and state the restrictions immediately. So here are my restrictions. X can't be equal to 0, x can't be equal to -2, and x can't be equal to -1. All those values of x would cause the denominator to equal to 0, and then you would have an undefined expression, okay? All right, so the other thing that we can do here is remember that in these rational equations, I want to effectively clear the fractions. And we've done this by multiplying all terms by the lowest common denominator. The easiest way to find the lowest common denominator, excuse me, is to look at the denominators right here and see, okay, well, I've got x, x plus 2, x plus 1 squared, and 12. So there are no common factors between any of these denominators, right? They all have unique factors. So I'm just going to multiply them all together. 12, x, x plus 2, x plus 1 squared. So I'm going to multiply all terms in this equation by this right here, and that will allow me to clear the fraction. All right. So I'm going to pause the video and I'm going to go ahead and write this out. Okay, you're going to see that I'm going to multiply all terms by the lowest common denominator. Okay, so as you can see, I took these two terms and I multiplied them by the lowest common denominator, and then the term on the right side right here I multiplied by the lowest common denominator. We'll now see how we can clear these fractions. So I have x times x plus 2, so that means this and this will cancel, so I've effectively cleared this fraction. And then over here, x plus 1 squared, that will cancel, and then the 12s will cancel over here. So I'm going to go ahead and now clean this up a little bit now that I've managed to clear the denominators. Okay, so the first term then becomes 12x plus 1 squared. The second term becomes minus 12x, x plus 2, equals x, x plus 2, x plus 1 squared. All right, you'll see that this is going to generate this has generated a polynomial equation. So I'm going to expand this all out and then move everything over to one side. So the next step right here is to expand this all out, and I'll do so on the next line. Okay, so the first thing that I did right here is I took x plus 1 and I squared it to get x squared plus 2x plus 1. It still has the coefficient of 12, right? So I'm going to have to expand in right there. I expanded in the negative 12x into this bracket, and I got negative 12x squared minus 24x. And this one right here required quite a bit of expanding. So I first had to expand this right here, x plus 1 squared, right? If you think about order of operations, exponents come first. So I expanded this, and then I multiplied all these together, and I ended up with this quartic on the right side. Okay, so I'm going to further expand this and then simplify after. Okay, so I distributed the 12, as you can see right here, into this bracket. And you'll see that I have 12x squared minus 12x squared, so that's going to cancel. And then I have positive 24x minus 24x, so that's going to cancel and equal to 0. So on the left side, I just have it equal to 12. Okay, so here we go. I've got the 12 on the left side, and then I still have this quartic on the right side. Recall that to solve a polynomial equation, one side has to be equal to 0. So now I have this quartic on the right side over here, and I have it equal to 0. I'm going to solve by factoring, so I'm going to look for, list all my factors of negative 12, and then see if I can find factors that would cause this to equal to 0. So I'm going to use the factor remainder theorem, right? And I find that 1 does work. So my first round of synthetic division will be as follows. I've got 1 over here, and then I use all the coefficients. 1, 4, 5, 2, negative 12. Bring the 1 down. Comes 1. This is 5. This is 5. That's 10. That's 10. That's 12. That's positive 12. And that's 0. All right, so let's go ahead and factor this out right here. So I've got x minus 1. All right, and then I have x cubed plus 5x squared plus 10x plus 12. So I already can see that 1 is going to be a solution to this rational equation that I have over here. And I can see 1 will work because it's not part of the restriction set right here. Right. This is still a cubic that needs to be factored. So again, I'm going to look at factors of 12 and see if anything works. And I will find that negative 3 does work. So I'm going to do another round of synthetic division. So I'll do negative 3 over here. Okay. And we're factoring this cubic right here. So I go 1, 5, 10, and 12. Bring the 1 down, negative 3 right there. That's 2. That becomes negative 6. This is positive 4, and then this is negative 12, and I get a remainder of 0. So I'll write 0 equals x minus 1, and then I have over here x plus 3, because I knew that negative 3 would cause this cubic to equal to 0. And I'm left with x squared plus 2x plus 4. This one right here is not factorable. So the only way to solve this quadratic is to use the quadratic formula. So I'll say that x is equal to negative 2 plus or minus the square root of 2 squared minus 4, a is 1, c is 4, all over 2a, which is just 2 times 1. So x is equal to negative 2 plus or minus, and then I have 4 minus 16, all over 2. And perhaps you can see already that we're going to generate some complex solutions over here. So x is equal to negative 2 plus or minus the square root of negative 12 all over 2. X is equal to negative 12. This can be the same thing as square root 12i all over 2. I look at square root 12, and that's the same thing as saying square root 4 times the square root of 3. And I know that the square root of 4 is just 2, so that's 2 root 3. So I can simplify this radical over here by stating it as x equals negative 2 plus or minus 2 root 3i all over 2. And then x is equal to negative 1 plus or minus root 3i. Okay, so I have some solutions here. I have 1, I have negative 3 as a solution, and then I have these two solutions right there. So therefore, x is equal to negative 3, 1, and then negative 1 plus or minus root 3i. And I can see that both 1 and negative 3 were not part of my restriction set, so these are in fact the answers to question 11. Thank you for watching.